I'm going to go through this a little bit, but we don't really, in ALEKS, we don't talk about the principal root. Principal roots would be the roots in the first period, okay? But if we have the sign of, let's just look at what this means, because there's something important here. We're saying that the sign of x is equal to 2/3. So basically we're saying y is equal to 2/3. So if y is equal to 2/3, notice I have this line here. That's where y equals 2/3. But there's many, many places on a sign graph where y equals 2/3, because we're not talking about the inverse right now. We're talking about the actual sign. There's an infinite number of places, right? So this says state the number of roots between 0 and 2 pi, where the sign of y, where the sign of x equals 2/3. So I have, between 0 and 2 pi, I actually have 2 places, don't I? Right? So there's 2 places where the sign of x is equal to 2/3. We know it's in quadrant 1 and quadrant 2. That's the 2 places that the sign is positive, right? The quadrant of the principal root would be quadrant 1. That's what they mean by the principal root. We don't really talk about that much right now. We're not really worried about that. Okay, so that problem really, I don't really like that problem very much. I'm not going to do a principal. Let's just find all solutions. This is more like what we need. So 6.6, 6.7, we start solving trigonometric equations. So let's start it so you have some idea, and we'll finish it up next week. So we start with saying, well, we have 2 cosine theta plus square root of 2 equals 0. So I'm going to say, well, let's subtract 2 from both sides. So I want to solve for theta. Theta equals what? That's my question. All right? So I divide both sides by 2, and I get cosine of theta equals minus the square root of 2 over 2. So what are my solutions between 0 and 2 pi where the cosine theta equals minus the square root of 2 over 2? So, like, I'm just going to walk you through what I want you to say. So quadrant what, reference angle what, and then I want the angles. Okay, you want to do it, Anka? I saw you were starting to say something. Or do you have a question? Yeah, so quadrant 2 and 3, reference angle pi over 4, theta is 3 pi over 4, and 5 pi over 4. Okay? Any questions about this? Okay, we're starting off a little simply. That's good. No questions. All right, good. All right, now we have tangent squared x. So who's next? Damien, you with me right now? I'll take advantage of it if you can hear me. Okay. If I lose you, I lose you. Okay, so how can I want to solve for x. Okay, do you think you can work with me, or do you want me to just go on to somebody else? Never mind, he's gone. Okay. All right, Hensky, your turn. So I want to solve for x. What do I do? Hensky? Can you hear me? All right. Let's see. Okay. Any takers? Delaney, you want to try it? Okay, Zach, you get the next one. Subtract one or add one, really, right? Okay, and then square root. Okay, good. So I have the square root of both sides. So I have tan x equals what? Good. Don't make that mistake. It's plus or minus 1. Perfect, Delaney. Many of you will make this mistake and forget the negative. It is, you've got to keep it. Okay, good. So what's my reference angle? Where is the tangent equal 1? Pi over 4. Perfect. And then what quadrant is the tangent of x equal to plus or minus 1? All of them. Exactly. 1, 2, 3, and 4. Perfect. In quadrant 1 and quadrant 3, it's positive, and in quadrant 2 and quadrant 4, it's negative. So what's my final answer here? Obviously, pi over 4. Pi over 4, 5 pi over 4, and 7 pi over 4. Perfect. Perfect, perfect. Does everybody get this? So there's 4 solutions between 0 and 2 pi. Okay. Okay, Zach. At least you get degrees. Okay, so how do I solve something like this? No. So think about it like this. Let's say I have 3x squared plus x minus 2 equals 0. Would I add 2 to both sides? No, I factored. Good job, good job. Can you factor this? Okay, good. No, I already have some. You can do the next one, Hensky. No, you solved it using the quadratic formula, didn't you? Yeah, you need to factor it. So this would be 3 cosine x, right? Because that would give me 3 cosine squared x. And then I have to have either a 1 and a 2 here or a 1 and a 2 here, right? So if this is a 1 and this is a 2, then this is a positive and this is a negative, and it's factored. Yeah, so that'll give you what x equals, or cosine x equals, but it's try to factor first. So anyway, So now we know that cosine of x is equal to 2/3, or cosine of x equals -1, right? Okay, so now, where does cosine of x equal -1? In degrees, actually. Good, 180. Now, we don't know where the cosine of x equals 2/3. That's not one of our points that we have memorized, right? So that is a calculator problem. So we can all do it on our calculators if you like. Let's see. Does anybody not know how to do this on their calculator? Everybody's calculator is going to be different. For mine, so most of them you would find inverse cosine. Which kind of calculator are you using, Griffin?
I use Google, I guess, if I need a calculator other than Alex.
Okay, yeah. Well, you'll have a calculator in Alex, by the way, for this. But if you just had a regular calculator, you would write in, you would type in somehow into your calculator the inverse cosine of 2/3, and it will give you back an answer. Does everybody have? If you have your calculator with you, you can try it. If you don't worry. It's a pretty basic thing in Alex. You just have to remember to put it in. For this one, yeah, I just rounded it. It'll tell you in Alex how to round it. So there's my two solutions, either 180 degrees or approximately 48.2 degrees. Is everybody with me? Good? All right. I don't know if I want to do this. Okay, it looks like they get harder quickly. Okay, I just don't know how far I want to go because we only have 15 minutes left. I don't want to leave you all confused here. Let's leave the finding all real solutions for next week. Let's do this one because this one we can do. Hensky, you want to try it, or do you want me to do it? You want to try it? Okay, good. So let's start. What do we want to do first? Do you have any, if you don't have any ideas, just tell me, and I'll kind of start guiding you through it. Are you frozen, or are you here? Oh, you're typing, okay. Well, sure. I'm not going to start it up, but I'll kind of guide you. So notice we have basically three different variables, don't we? We have a sine squared, a cosine, and a cosine of 2 theta. So we need to make it so that, like if we had y squared plus x squared minus 3z equals 1, I definitely can't find a solution for that, right? So I have to get it down to one variable. So this is where you have to start by using your identities. And I would say first identity you need is you need to change this to just thetas. Because right now we have one variable that has 2 theta, and there's nothing we can do with that. We can't combine it with anything else. It's like trying to combine 2x plus y. It doesn't work. So if we can get them all to the same variable, that's helpful, isn't it? So do you know the identity for cosine 2 theta? If you don't have it memorized, don't look it up because I know it. Okay. So cosine 2 theta is the same as cosine squared theta minus sine squared theta. Okay, that's the identity. And then plus sine squared theta minus 3 cos theta equals 1, right? Okay, now what? This one you got, Hensky. I'm not going to guide you through it. This one you got. The cosines are different, though. One's cosine squared. So if you had x squared minus 3x equals 1, would you combine those? Okay. Don't make that a question. Hensky, that's not a question, right? Okay. So what am I going to do? There's a very obvious next step here. This is algebra. Right now, it's just an algebra question. What does that mean? How would you subtract the cosines? What would you get? What would you get if you subtracted the cosines? Just tell me, if you subtract the cosines, what do you get? I don't understand what you're saying, so I want to know what you mean. So go and subtract the cosines and give me your answer. So the answer to this is minus 2x Jackson, what can I do next? Jackson. John, what's up? No, Griffin, not yet. Yeah, I cancel the signs. I have minus sine squared plus sine squared, 0. Minus x squared plus x squared. Gone, gone. So now I end up with cosine squared theta minus 3 cos theta equal 1. Right? Now what do I do, Pensky? Okay. Jackson, what do I do next? Anybody, what do I do next? Well, the cosines are all the same now. I factor, but first I have to subtract 1. No, I wouldn't use the identity for cosine squared, because now I have cosine squared theta minus 3 cosine theta minus 1 equals 0. It's the same thing as x squared minus 3x minus 1 equals 0, isn't it? I'm waiting, Laura. What's up? Got it? I just changed it to an x. I said cosine theta equals x. Okay, good. I'm going to erase this though, because even though you can do that, I'd like to let you look at it like as if it was. You can change it. It's okay with me, but I want you to start really looking at it like they're just variables, and I'm going to now. Can I factor this? Yeah, I can't factor it, so I have to use the quadratic formula. So this is where I would have to use the quadratic formula. So I would say theta is equal to negative b, so it'll be plus 3, plus or minus the square root of b squared minus 4ac all over 2a, right? So it equals 3 plus or minus the square root, so this is plus 4, 13 over 2, and then I just solve. So I have theta equals the inverse cosine of 3 plus. If someone has their calculator and knows how to do this, if you can just give me the answer, that'd be awesome. Or theta equals cosine of 3 minus the square root of 13 over 2. Is anybody trying, or do me do it? Is anybody doing it? If you're doing it, just raise your hand and I'll wait. If not, I'll do it. Okay, it's like nobody's doing it. Who cares? I'm not going to do it either. The answer is whatever it is. But that's what you would do. You put this into your calculator. Sorry, actually inverse. Not cosine, inverse cosine. My bad. Yeah, sorry, that's my fault. Because cosine theta equals those two things, so inverse cosine in degrees. (107.6), and the second one comes out to an error. It could come out to an error because, let's see, that is, so 3 minus square root of 3 over 2. It doesn't matter. So the first one is, it could come out to an error, 107.6. Okay, let me just do it real quick to make sure. If it's less than -1 or greater than 1, it's not going to give you an answer, right? So it could be undefined. Oh, the second one. Oh, the second one comes out. The minus comes out as 107.6. The first one, oh yeah, that's going to be too big. Because this is already, 3/2 is already bigger than 1. So this part gives you, I should see that. So that's going to be greater than 1, so there's no solution for that. So there's only one solution here, 107.6. Actually, that's not true. This is where it gets really complicated. So I'm going to tell you there's 2 answers here. So I'll do it like this. I'm going to give you a new page. So we know that the inverse cosine of 3 minus the square root of 13 over 2, I think it is equal to 107.6, right? So that's over here in quadrant 2. So, but there's also another place where the cosine is negative, right? Because here the cosine is negative. Is that correct? So pay attention. We'll go over this again next week. So the other quadrant where the cosine is negative is quadrant 3. So I find my reference angle. My reference angle is 180 minus that, so that gives me 72.4. So theta sub r is equal to 72.4. So I have that angle, and I also have that I have 180 plus 72.4. So I have 2 solutions. The 2 solutions that I have are for that this one angle here. This one angle here has 2 solutions. This definitely is undefined. So